Let's take a look at 2 sine squared theta is equal to 1 and try to solve for theta in radians because that's what I have here on my unit circle using inverse functions. So the first thing that I want to do is divide both sides by 2 to get my sine squared theta by itself. So I get sine squared theta is equal to 1/2. Well, I have this squared, so let's take the square root of both sides. And so I get sine theta is equal to, now when we take the square root, we know it can be either plus or minus, so it can be either a positive or negative. The square root of 1 is 1, and I have just plain old square root of 2 at the bottom. Can't leave it like that though, so I'm going to multiply the top by square root of 2 and the bottom by square root of 2 to rationalize, and I get plus or minus root 2 over 2. And I have that on my unit circle. So let's look at all the places where it's a positive root 2 over 2 or a negative root 2 over 2 for sine. So here we have it in our first quadrant. So that is pi over 4. Here we have it, which is 3 pi over 4. We also have it here, which is 5 pi over 4. And we have it here, which is 7 pi over 4. So we have it in every quadrant. So now we need to ask ourselves, well, what's one way that I can write this where I'm including all of the values and I don't leave anything out? Well, let's take a look at pi over 4 to 3 pi over 4. So from pi over 4 to 3 pi over 4, it's a unit of pi over 2. So the difference between them is pi over 2. So I know that I can add any iteration of pi over 2. So I can do where k is an integer. So it can be a positive integer or a negative integer, right? These are all the different solutions that it can be. And I hope that this helps.